Okay, and let's start with a definition. Always a good way to start, isn't it? So by files, we're referring to files that are stored permanently, or maybe say data that's stored permanently in a file that's external to our program. Because remember, we can store things temporarily within the context of our program, and we can have variables or objects of other classes which will hold data. But the problem is that data is going to be flushed from the memory. It's going to be deleted. Remember, Java has automatic garbage collection when the program ends. So Java is going to clear up all that memory, and won't have a file or data that persists outside of the lifetime of that program running. Okay, so if we want to store data permanently, then we have to record it. We have to store it external to our application. So let's start with some other definitions then. So a file is a named block of externally stored data. Yeah, we've covered that. Okay, and then a record within that file is a single data instance. So actually, we could potentially relate that to objects here, couldn't we? A person object or a stock item object or a student object. And then those objects, they store fields, or we could relate that to variables, couldn't we? Attributes of an entity that we have a value for. So a name, a stock number, an ID, an exam mark. So a file is made up of multiple records, and then each record is made up of multiple fields, multiple attributes. Okay, so it's a nested system again there. Okay, so let's move on then. Right, so we've seen streams being used, even if we haven't actually mentioned it in great detail. We have seen it being used before when we've input data into our programs and also printed data to the screen. Okay, we've used EasyIn or the scanner to form a connection between the hardware and the software. And this connection, otherwise known as a channel or a stream, okay, and that's a way of being able to translate data from the hardware to the software. Okay, so the operating system forms this, what's known as a standard input stream from the keyboard to be able to input data into our program. So we're going from hardware to software. That standard input stream is going to manage that translation between the two layers. And then likewise, we just reverse the process when we want to output data to the screen as well. We have a standard output stream, which will go from software, what we have in our programs and our variables, and then print that to the hardware, the actual screen, so we can see the values for that. So that's the standard output stream. So we've seen this before when we've put data into our programs and put data to the screen. We're just going to translate that concept now for writing data to a file rather than to the hardware, rather the screen. And we're also going to do that for input as well. Rather than input from the keyboard, we're going to get it from a file. We're going to read data in from a file rather than from the keyboard. Okay, so that concept of a stream, a channel between those two layers, is still the same. Okay, and by stream, as we said before, think geography here. Think of a flow of water, flows from the source. Okay, you could think of a stream in programming terms as the flow of data rather than water. It's just a flow of data, whether that's going from the hardware to the software, software to the hardware, or from files to software, software to files. Okay, it's still the same concept of this flow of characters. That's what we're referring to here, flow of data. So the program's only going to look at one character at a time and process that in a flow. So the standard input stream, we could refer to that as a buffer as well. It's another word for it. So it's a flowing buffer of characters. Okay, those characters are read in one at a time, one after another. The program may not be aware of how much data is going to be input, so it's just a continuous flow until the user essentially ceases that. With inputting from the keyboard, we press enter, don't we, to stop the flow and move on with the program. And likewise with outputting to the screen, it's just going to continuously output one character after another to the screen until it gets to the end of the, whether it's a string, literal. The same process with a file as well. We're going to read in data from a file, one character after another, and then also write to a file one character after another. So that's where the concept of a stream comes from, this continuous flow of data. Okay, let's continue with that theme and let's look at how we might read data in from a file. As we said, if we set one up and it's a text file, we can do text encoding. How could we get that data, the student data for myself and Frank and our IDs, how could we get that into our program so that we might then want to display it to the screen and we might want to eventually come to write data back to the file. Okay, so let's take a look at this then. So the java.io package contains a class named FileReader. Okay, that's specifically designed to work with text files. That's good. And then within that package, there's also a input stream reader, from which I think FileReader is a subclass of input stream reader. That can be used to read console input by converting a byte stream into integers that represent the Unicode character values. Okay, so like ASCII there, and then it converts back to the characters. All right, so FileReader descends from input stream reader, and within that we're also going to want to refer to the readline method of buffered reader. So there's two classes here. We've got buffered reader and we've got file reader. So the sequence is that the file reader object is encapsulated within the buffered reader. We'll probably want to pass the object of file reader to buffered reader so that we can then call readline on it. Basically, we're setting up the stream between the two layers, aren't we? That's what we're doing there. We're going to see that in just a moment, and we must call that from must call the readline method of the buffered reader from the within a try and catch block, because that could throw an IO exception. Remember we said about Java, it's going to check those IO exceptions, so we've got to have something in place to catch them, otherwise it's not even going to let us run the program. That's done at compilation stage, not at runtime stage. Okay, it's going to check to see whether those files exist beforehand. If not, it's going to throw an exception. So we need to be able to handle that. All right, and then of course we can do this iteratively. Once we've got everything set up, we can then loop through the file, reading one line in after another, and we can then store that or print it straight out to screen. Okay, and at the end of the file, once we've reached the end, remember it's a serial access, so we can go from start to finish. Once we get to the end of the file, it will return a null value, which indicates the end of file, also known as EOF. You're going to see that in the code, and that can be used to indicate that we've got to the end of the stream, and then we terminate the loop. Okay, so yes, let's have a look at some code here so that you see this in full. Right, so in Student Tester, in a main method, we've got a try block, which we've got an instance of FileReader, as we said, that represents our file. It's going to read in from a file, so not a file per se, we've actually got a file reader. It's different. It takes the file as the parameter, but it has that stream, it's got components within it to actually read from this file. So we're pointing it towards student.txt. Now, the instance of this, the representation of this file is student file, and then we pass student file to buffered reader, okay, which presumably completes the stream between the two. We've got the representation of the file, and then we want to create a channel, create a stream so that we can access and retrieve information from this file. The particular instance is called buffer, so what we then do is we've got a temporary string variable called line, and then via the buffer object we're going to invoke readline to get a particular line, which presumably is just one line at a time, store that in line, and then if we're not at the end of the file, so basically we're going to keep doing this until we get to the end, we just print that to screen. Okay, so we're not necessarily going to be storing all the lines, that's just temporary storage, which is then overwritten each time, or technically creating a new string object and pointing towards that one. We just basically all we're going to see at this end is just that data from the file printed to the screen. Okay, and then when we get to the end of the file, we'll then close the stream. And if there was a problem, we can then catch that via the IO exception. So that's quite a general error. It's not going to give us anything specific, just related to the reading of a file. But we must have that catch block. We won't actually be able to run the program without it. Okay, because remember it's checked. It's not going to let us run the program otherwise. So if we were to run this, we're not going to run it just yet. We're actually going to see a more succinct version of this. Okay, yeah, so we had quite a lot going on, didn't we? We can actually condense all of that. But I think we've just moved that if statement. We've put it within the context of the while, basically to say attempt the read, and then whilst that is not returning null, keep doing it and keep printing it to the screen. And then once it has got to the end and it returns null, we then jump out, close the buffer. Okay, so two approaches there. They should give you the same response. And then we should see the contents of that file represented in text format like this. Okay, so that's in nice formatting. That's a line at a time, which represents the file quite nicely within our console program. Okay, as we saw earlier, that text file has now been, the formatting of that's mirrored quite nicely here. Okay, so that's reading in from the file via the input, the file reader, and the buffered reader.